Hi, I'm Sachin. I'll be solving problem 1 of homework 3. The first question says that p of x equal to k given a into k 1 by 3 to the power k minus 1 where k goes from 1 to infinity. So the first sub question says find a such that p of x equal to k represents probability mass function. From the properties of probability mass function, we know that summation of p of x is equal to k should be equal to 1. So substituting that, we have summation k is equal to 1 to infinity ak into 1 by 3 to the power k minus 1 to be equal to 1. So since a is a constant, let's take it out of the summation. So we have a summation k into 1 by 3 to the power k minus 1 is equal to 1. So we can rewrite this as a into summation k is equal to 1 to infinity 1 by 3 to the power k divided by 1 by 3, because it's 1 by 3 to the power k minus 1. So that's equal to 1. So since 1 by 3 is in the denominator, this becomes 3a into summation k is equal to 1 to infinity 1 by 3 k into 1 by 3 to the power k equal to 1. So let's start substituting values for k and let's arrive at the summation. So if you substitute k is equal to 1, we have 1 into 1 by 3 to the power 1 plus substitute k for 2, we have 2 into 1 by 3 to the power 2 plus 3 into 1 by 3 to the power 3 and so on until infinity terms. This entire summation should be equal to 1. So we know that from probability of summations, we can split this summation as 1 by 3 plus 1 by 9 plus 1 by 27. That this is a GP series, which is summation is a by 1 minus r, where a is 1 by 3 by 1 minus 1 by 3. So here we have 1 by 3 divided by 2 by 3. So that is 1 by 3 into 3 by 2, that is half. So if we keep doing this for every summation, we have the final result to be 3a into the entire summation goes from the 1 into 1 by 3 plus 2 into 2 by 1 by 3 the whole square plus 3 into 1 by 3 the whole cube. So we have 3a into 3 by 4. The entire summation of that gives us 3 by 4. So 3a into 3 by 4 is equal to 1. So we have a is equal to 4 by 9. So a is equal to 4 by 9, and only then p of x equal to k is equal to a into k 1 by 3 to the power k minus 1 represents a probability mass function. Now the second sub question says find e of x. So we know that e of x is integral minus infinity to infinity x into f of x dx. But in this case, e of x is summation with k, a k into p to the power k minus 1 into k. So that becomes a k square p to the power k minus 1. So now we know that summation a into p to the power k is equal to a by 1 minus p. So now let's differentiate both the sides. Differentiating both the sides, we have summation a k p k minus 1. Differentiating with respect to k, we have differentiation of p to the power k as k into p to the power k minus 1 is equal to a by 1 minus p the whole square. So this is again equal to 1. So we get a is equal to 1 minus p the whole square. We have generalized p. Here in our case p is equal to 1 by 3. We have just substituted 1 by 3 to be p so that the derivation becomes simpler. So now we need one more term of k. So differentiating this again with respect to k. Differentiating the second time. So we have a into k square p to the power k minus 1 again. So this we get a into 1 plus p divided by 1 minus p the whole cube. But we know that a is equal to 1 minus p the whole square. So substituting this in the above equation, we get summation a k square p to the power k minus 1 to be equal to 1 plus p divided by 1 minus p. And substituting the value of p as 1 by 3, because in our main question, the question says a k 1 by 3 to the power k minus 1. Just for our simplicity, we have substituted p to be equal to 1 by 3. So substituting p to be 1 by 3, we have e of x to be 1 plus 1 by 3 divided by 1 minus 1 by 3. So that gives us e of x to be equal to 2. So this is our answer for the second sub question of the first question. Find e of x. E of x, we get it to be 2. The third sub question says find e of x square. So in order to find e of x square, we need to find a k to the power 3 p of k minus 1. But we know from the previous derivation that summation a k square p to the power k minus 1 is 1 plus p by 1 minus p. So now let's just rearrange this summation. We have a k square p power k. Let's take the p in the denominator here to the other side. We have p into 1 plus p by 1 minus p. Now let's differentiate the above equation again. Differentiating this, we have a k square p to the k into p to the power k minus 1. So that gives us summation a into k cube p to the power k minus 1, because this is what we want. This is indirectly equal to e to the power x square. So let's differentiate the right hand side with respect to p. So differentiating the right hand side with respect to p, we get 1 plus 2p minus p square divided by 1 minus p the whole square. So if we differentiate this entire right hand side with respect to p and applying the UV rule and other things, we have 1 plus 2p minus p square divided by 1 minus p the whole square. In our problem, we know that p is equal to 1 by 3. So substituting this, we have e of x square to be equal to 7 by 2, that is equal to 3.5. So we get e of x square in the third subdivision of the first question to be equal to 3.5. The D subdivision of the first question says find conditional probability mass function, and it's given p of x is equal to k, given that 1 less than or equal to x less than or equal to 10. So now we know from the basic probability formula that p of a given b has occurred as probability of ab divided by probability of b. So substituting this formula, we get p of the x is equal to k happen that given 1 less than or equal to x less than or equal to 10, we get probability of x equal to k, 1 less than or equal to x less than or equal to 10. So divided by probability of 1 less than or equal to x less than or equal to 10. So finding the intersection of this, we get when x is equal to k and when x lies between the range 1 to 10. We know that k ranges from 1 to infinity, 1, 2, 3, 4 up till infinity. So the intersection of probability of x is equal to k and x lying in this range, because we know that k can take any value from 1 to infinity, and immediately we have the delimiting range of 1 to 10. So if we just apply this, we get probability of x equal to k with 1 less than or equal to x less than or equal to 10 divided by, and from the applying the formula that fx of x is equal to probability of x less than or equal to x, we get fx of 10 minus fx of 1. So using this formula, we get p of x is equal to k, given that 1 less than or equal to x less than or equal to 10, we get probability of x equal to k intersection with 1 less than or equal to x less than or equal to 10 divided by fx of 10 minus fx of 1.